Hi, we're back. This is my new process. Now I'm probably going to be working on this a lot. This is what it is. We just got some copper tubing and we got the magnesium strips. You can get coils of this on Amazon for like, you can get several coils of this for $10, $20, depending on how much you buy. It's not that expensive. It's cheaper than the core. And my opinion is that this has to do with the amount of current you get out of these has to do with the surface area of contact between the crystals and the metals. And so that's why I tried to go with this. And I actually made one of these that was 4 of these or 3 of these stacked on top of each other, and it's got an LED coming off of it. And I've got it stuck in my yard. We're going to see how it does over time as a night light, a yard light. And I've got it sealed up with these. We found out that if these dry out, which I sprayed some water on this one this morning. If these dry out, they don't produce much voltage at all. But we'll see what we got on this one right now. This is one that one of my students made in the morning a couple of days ago. And let's see what we got on. And when you're testing these with the meter, you got to realize that this magnesium oxidizes, so you need to like scratch into it so that you're getting a good contact with it. And the same thing can happen on the copper. The copper's not as bad. So we're getting 1.43 volts and very few amperage, very little amperage. So what I decided to do after I made the yard light was I decided to, and by the way, how these are made, we just take a towel. This is a good example right here. We just take a towel and we soak it in a solution. So we got I'm gonna bring this over here. So we got a solution here of Epsom salts. That's all I used on these. And the reason I used just Epsom salts is because I saw a video on Bedini. John Bedini stated that the Epsom salts doesn't corrode the copper, and it looks like he's right. As you can see in those, you've got the green right around the copper. It's corroding the copper. Where I've got borax and alum and all that other stuff in there. But this is just an Epsom salt solution, and it seems to produce the same amount of voltage. Now, as far as current goes, I'm not sure. I'll have to test that. Then we'll let you know in a future video. But basically, I used these towels. These are those auto shop towels. They're a lot tougher than just regular kitchen towels, and that's the reason I went with them. But we just soak this in the Epsom salt solution, wrap it as tightly as we can around the pipe, because remember, you're trying to make as much contact between the crystals and the metal as possible. And then wrap magnesium wire around it. And as you start, you have to anchor so you can get a good tight wrap. Because if your wrap's loose, you're not going to make it contact. So you're going to need a good tight wrap around it. And I just do it like that. And you don't want to let it overlap. And you're just trying to get as much contact as possible. Now I've determined we're using a 4-inch piece of copper and then 3-inch towel. And I've determined we're getting about 3.5 square inches of contact surface using this method right here. And that's just an estimate. It's not exact. So what I've done is I've made a battery of cells. That's where the term battery comes from, by the way. And I've got 4 cells together in parallel, and then I've hooked 4 of those 4 in series. And you see I've drilled a hole. We're going to add one more because we're not getting the results we wanted. I mean, we've already done the LED thing. We're running a little circuit thing, and so we wanted to move up to the next step to run a motor, but we haven't quite got there yet. So I mean, you can see this. I've got 10 LEDs here. I've pulled one up for something. Oh, no, that's not. So I've only got 9 LEDs. I got 9 LEDs here. And first of all, with no load, this measures 5.8, so almost 6 volts. 5.85 volts. And it's been sitting here for a while without a load on it. Now once we put a load on it, let's just go ahead and measure it this way. Just put my meter on the battery. And we'll hook the battery up to these LEDs, and see we got the 5.74, so we're not getting as much contact. And so we can hook up 9 LEDs and puts them out pretty bright, and then you'll see them dim down after a while. They drop down to 4. See the voltage is dropping down. It'll level off at about 3.45 or something like that, just under 3.5. We're at 3.6, 3.5. I want to go ahead and let it level out. And you can see they dim a little bit. That's 9 bright white LEDs that is illuminating. And for those of you that don't know anything about LEDs, the bright whites take more voltage than like an amber or a red. This is an amber. And you'll notice here, if I hook an amber up in here, I get it hooked up, it will shut off the bright whites because it operates at a lower voltage, and you'll notice your voltage dropped here. So if you're first starting out and you're trying to test these batteries, you might start out with an amber and then work your way up to the bright whites and the blues. Bright whites and the blues are the ones that take the higher voltage. Okay, so that's that. The goal here is to drive a motor. When we did some calculations on this, and the way we did it was just by measuring the voltage across the resistor and determining the current from that and using Ohm's law for the whole circuit, we're getting anywhere from 7 to down to 5 milliwatts of power coming out of this. So I just, for the fun of it, I thought I would try to run a motor. Now this is a dilemma that I've come up with, that I've run into, and I don't know why this works or doesn't work. And maybe some of you electrical engineers out there, somebody can tell me why this doesn't work. All right, this is a little motor that's supposed to run at 1 volt. It'll run at 1 volt. And I know it'll run at 1.5 volts. It's got 1.8 volts on here, and yet the motor's not running. But if I take this battery here and hook up to it, which is a 1.5 volt battery, I might need some assistance. Let's see if I can do this. Yeah, I'm gonna ask Braxton to hold that. Yeah. What we're gonna do, we're gonna go ahead and use the meter here so we can see the voltage while since we've got the assistance. So you can watch the meter as I hook this up. If I can get this hooked up. Okay, you can hear the motor's running. I don't know if you can hear that or not. The motor's running. It's at 1.48 volts. So, and that's running off of a little AAA battery. But, let's go ahead and hook this back up. This is one reason I wanted to do this video today, because I've run into this dilemma and I want to see if anyone knows the answer, and I'll post it probably tomorrow. Post it this evening. Just get it done. And I know I need to join some of the forums that you guys are in so I can get some more exposure. There it is, 1.8 volts, and it's not running, but it runs at 1.4 volts. How can this be? I don't know. Maybe it has to do with the resistance of this battery versus the resistance of this battery. This battery probably has a much lower resistance. I'm not sure. I'm not sure how you can get that voltage on here and it not run. And maybe one of you guys can explain that to me. Okay. So that's my funny little dilemma. But we are going to add cells to this to see if we can get more current out of it. That's my desire right now, is to get as much current out of this as possible. I mean, I saw Laser Saver take just one of these cells and run a little motor off of it. But for some reason mine won't. These cells will not produce enough to run one motor. So maybe I'm not making them right and I need to work on it. And I will. All right. We also found out, like I said, that if these dry out, they die. So we've been wrapping and sealing them up completely in tape. I'm going to try to find a tape that's not just electrical tape, but something that's can withstand some heat, so I can bake these in the oven and seal them really good, and just drive all the water out of them and do them like this, because these are baked and dried. There shouldn't be any water in them, and they're still running. I can still see this thing flashing. Can you see it there? Oh, no. The circuit's still running. It's been running since the 9th, so it's been running over a week. And we'll just keep letting that run, see how long that runs. All right, so then the next thing we're going to do You can see I've got some towels here. I had some spillage, and so I just added a little alum and a little borax to it, and I'm soaking these towels in it. I just got it wet and soaking the towels in here. And we're just going to cut squares and put on this is just a regular old blank circuit board. This is a 4x6 circuit board. And we're just going to make 8 separate cells here. So we'll just cut a piece of this, put it on there, put a piece of magnesium strip on it, tie them all together in series and see what it does. And I'll probably present this in a later video. That's all I got today. Please post a comment if you know answers to any of these problems that I'm having. Thank you.